Hi, I'm Sven. One more thing about artificial intelligence and optimization. Sometimes we are asked whether the mathematical mojo we are doing every day is artificial intelligence. The answer is, it depends. So today, let's have a look at artificial intelligence, machine learning, mathematical optimization, and their relationship. Welcome to Optano. For quite some time, people are talking about artificial intelligence and machine learning, but often even experts mix up these terms and use them interchangeably, where it would be more precise to stick to one or the other. So here's the difference. Assume we want to pick the best decision out of a bunch of variants of different quality. With mathematical optimization, we model all factors that impact the quality of a decision. So we need to know all the potential relations and dependencies. Then, using clever mathematics, we calculate the best solution, or at least a very good one, and provably so. But sometimes we don't know all the factors or relations that influence a decision. But maybe we have a lot of past data where such a relation might show up. Then we can do two things. We can try to learn how the data we can observe relates to the quality of a past decision. And this way, we can kind of learn from the past and make a guess at how good a future decision might be. Also, we can use such knowledge to interpolate future trends like forecasts, maintenance needs, and so on. This is what we can do with machine learning. And although there is statistics and math at its heart, it's not the same as mathematical optimization. And while optimization and machine learning are categories of methodologies, the term artificial intelligence describes an overall vision. Historically, it was meant to define an all-purpose problem-solving system. But nowadays, it's a generic term to capture various problem-specific methodologies, like machine learning or mathematical optimization. They seem to behave intelligent from a quite emotional point of view. You know, as machine learning was still called statistics, it was not quite as fancy as today. In practice, optimization and machine learning go side by side. For example, when we use machine learning to find the best set of solver parameters for a complex optimization problem, we always need to examine the problem at hand and then pick the proper method to solve it. No buzzword will change this. Mathematical optimization and machine learning are just two categories of the broad field of methods that we call artificial intelligence. They are neither the same nor is one better than the other, but they all solve specific types of problems. And a good analyst should have both of them in their toolbox. But when I think about it, there is something looming at the horizon that will have an impact on this toolbox, so maybe you should check out our next episode about quantum computing. See you next time and stay safe!